Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0113, indicates an issue with the intake air temperature IAT sensor circuit, specifically pointing to high voltage in its reading. This code is crucial as it helps the engine control module, ECM, manage engine performance effectively by monitoring the air temperature entering the engine. The IAT sensor is typically located in the air intake duct or as part of the mass airflow (MAF) sensor assembly, where it measures the temperature of the incoming air. A malfunctioning IAT sensor can lead to performance issues, as the ECM may not compensate correctly for the air density and temperature, affecting fuel mixture and overall engine efficiency. Understanding this DTC is essential for technicians troubleshooting a Honda Pilot from 2016 to 2022, as it ensures that the vehicle operates at its optimal performance. Correctly diagnosing this code will enable you to focus on maintaining or replacing the faulty component to restore functionality. The intake air temperature IAT sensor plays a vital role in monitoring the temperature of air entering the engine. This information allows the engine control module, ECM, to make adjustments to fuel injection and ignition timing, ensuring optimal engine performance and fuel efficiency. In the Honda Pilot, the IAT sensor can often be found integrated within the mass airflow (MAF) sensor or positioned within the air intake system. When the DTC P0113 is triggered, it suggests that the voltage occurring at the IAT sensor is above the expected range, specifically exceeding 4.92 volts. This high voltage signal can mislead the ECM, potentially causing rich or lean fuel mixtures, impacting engine response and efficiency. Properly diagnosing this code is crucial to ensure that the vehicle maintains its performance standards and adheres to emissions regulations. Understanding the possible causes for DTC P0113 is essential in effectively diagnosing the issue. One primary cause could be a short circuit within the connector or wiring leading to the IAT sensor, which could result in high voltage readings. A faulty IAT sensor itself can also trigger this DTC, indicating an internal failure or abnormal resistance. Additionally, poor connections or loose terminals at the MAF sensor or the powertrain control module (PCM) can contribute to intermittent high voltage signals, leading to temporary faults. It's also worth considering the PCM's condition, as electronic malfunction in this unit can misinterpret sensor data, leading to erroneous high voltage readings. Each of these areas must be examined thoroughly to pinpoint the root cause of the problem. When DTC P0113 is present, several symptoms may manifest in the vehicle's operation. One may notice a decrease in engine performance, including rough idling or stalling, as the engine struggles to adjust to incorrect air-to-fuel ratios. Increased fuel consumption may also be observed, as the engine may compensate for the perceived high temperature by injecting more fuel. In many cases, the check engine light, CEL, will illuminate on the dashboard, alerting the driver to a problem within the vehicle's engine management system. These symptoms not only affect the driving experience, but can also lead to more severe engine issues if not addressed promptly. Thus, it is crucial to respond quickly to these indicators and perform the necessary diagnostic steps outlined for DTC P0113. The first step in troubleshooting DTC P0113 involves verifying the problem by turning the vehicle to the on mode without starting the engine. During this stage, it's crucial to use the Honda Diagnosis System, HDS, to check the voltage parameters of the IAT sensor. Specifically, the voltage signal should be monitored to see if it exceeds the threshold of 4.92 volts. If the observed value matches or exceeds this threshold, it confirms that the failure is duplicated and you can proceed to the next step. However, if the voltage appears normal, it indicates an intermittent failure, possibly due to poor connections or loose terminals at the MAF or IAT sensor. Checking for freeze data or onboard snapshots may help in replicating the failure under specific conditions, aiding further diagnostics. In the second troubleshooting step, ensure the vehicle is turned off. Then, disconnect the MAF sensor IAT sensor 5P connector. This is a crucial move that allows for a clearer diagnostic evaluation. Next, you will need to connect terminals A and B of the 5P connector using a jumper wire. Terminal A corresponds to the number 4 position and terminal B to the number 5 position of the connector. Once the jumper wire is in place, turn the vehicle to the on mode again and use the HDS to measure the IAT sensor's voltage. If the reading exceeds 4.92 volts, continue to the third step of the troubleshooting process. However, if the voltage fails to meet the threshold, it suggests that the MAF sensor or IAT sensor may need replacement as they are likely defective. For the third step in the troubleshooting process, it's necessary to remove the jumper wire that was connected in the previous step. With the vehicle off and the MAF IAT sensor 5P connector disconnected, your next action is to turn the vehicle on again and measure the voltage between two specific test points. Test point 1 corresponds to the number 4 position in the MAF IAT sensor connector, while test point 2 is a body ground. You should be looking for a reading that's approximately 5.0 volts. If this voltage is present, it indicates that the wiring to the sensor is intact, and you can then move to step 4 for further diagnostics. If the voltage reading is not around 5.0 volts, it suggests potential issues further down the line that need to be addressed. Step 4 requires you to turn the vehicle back off before jumping the SCS line with the HDS and waiting for a minimum of 1 minute, ensuring accurate readings. After waiting, disconnect the PCM connector A. This action enables you to check for continuity between two specific test points. You will measure continuity between test point 1, which is number 5 of the MAF IAT sensor 5P connector, and test point 2, which is number 20 of the PCM connector A. A continuity test will reveal the condition of the SG6 wire. If continuity is detected, it confirms that the wiring is operational, and you should investigate any related service information regarding DTCs. However, if there's no continuity, it indicates an open circuit in the SG6 wire that requires repair between the PCM and the MAF IAT sensor. In the final step of troubleshooting for DTC P0113, once again start by turning the vehicle off and jumping the SCS line with the HDS for over a minute. Following this, disconnect PCM connector C to evaluate the condition of the TA wire. Similar to the previous steps, you'll conduct a continuity check between the MAF IAT sensor 5P connector number 4 and the PCM connector C number 49. This will determine whether continuity exists in the TA line. If continuity is confirmed, it indicates that the wire is functioning correctly, allowing you to consider other components or take further diagnostic steps. Conversely, if continuity is absent, it indicates a break in the TA wire between the PCM and the MAF IAT sensor, requiring appropriate repairs. After completing the troubleshooting steps for DTC P0113, it is essential to conduct a final verification process to ensure successful repairs. Begin by rechecking all connections made during diagnostics to confirm that they are secure and properly seated, as loose connections are a common cause of false readings. Next, Utilize the HDS to confirm that the voltage readings from the IAT sensor are within the normal range. Once connections have been verified and appropriate voltage levels confirmed, it is advisable to perform a test drive. Monitoring the vehicle's performance during this drive will help ascertain whether the initial issues leading to the DTC have been resolved and that no check engine light appears again during operation. This final step ensures the vehicle's reliability and performance are restored. To prevent DTC P0113 and related issues in the future, it's crucial to implement some preventive maintenance measures. Regular inspections of the wiring leading to the IAT sensor and MAF sensor play a critical role in identifying potential damage, such as fraying or corrosion, which can hinder performance and lead to errors. Additionally, keeping the sensor connectors clean and free from dirt or debris helps ensure secure connections and proper signal transmission, reducing the likelihood of fault codes. Lastly, keeping the vehicle's software updated can prevent compatibility issues and ensure that the ECM operates with the latest specifications and adjustments from the manufacturer. By consistently performing these maintenance tasks, you can prolong the life of the components and enhance overall vehicle reliability. In summary, DTC P0113 is a significant code related to the high voltage reading from the intake air temperature sensor, which affects the engine's performance and efficiency. The comprehensive troubleshooting steps outlined provide a systematic approach to identifying the underlying issue, from verifying current conditions to checking wiring continuity. Understanding the role of the IAT sensor in managing air-to-fuel ratios highlights the importance of addressing this DTC promptly. Implementing preventive maintenance measures, such as regular inspections and ensuring clean connections, can mitigate the risk of future DTC occurrences. Ultimately, being vigilant about these aspects will help enhance vehicle reliability and performance, enabling a better driving experience for Honda Pilot owners from 2016 to 2022. Please like and subscribe to the channel. See you next time.